When we talk about the odds of an event, a lot of times we confuse it with probability. Basically, if you think about probability, we think about it as the number of favorable outcomes over the number of total outcomes, or the number of successes over the number of trials. That's probability, both experimental probability and theoretical probability. We take what we want to have happen over the total number of things that can happen. Odds works a little differently, similar but different. If you look here at our definition of odds, it says our number of favorable outcomes over the number of unfavorable outcomes. Now, instead of comparing what we want to the total number, we're going to compare what we want to what we don't want. So, for example, I rolled a number cube dice, and I could get a 1, a 2, a 3, a 4, a 5, or a 6. Well, if I do that, let's say, what is the odds that I get a 5? So the number of favorable outcomes is just 1 because there's only one 5 that's going to appear. But instead of comparing it to saying there's 6 total, I compare it to the number of times there's not a 5 that's going to come up. In this case, it'd be 1, 2, 3, 4, 5. So the odds of rolling a 5 are 1 to 5. 1 that it's going to happen, but 4 chances that it's not going to happen. Again, odds and probability, similar, but there is a major difference. Let's look at this example. You randomly choose a letter from the word summer. What are the odds that the letter is a vowel? So if we're talking about odds, and we're talking about the number of favorable outcomes, well, that's us randomly selecting a vowel. What are the unfavorable outcomes? You could say not a vowel. You could say randomly picking a consonant. I apologize if I spell anything incorrectly here. But we're going to take our favorable outcomes and compare it to our not favorable outcomes. Vowels to consonants or vowels to not vowels. Let's just start by looking at vowels. If I look at this word summer here, U is a vowel and E is a vowel. So how many vowels could I randomly select? 2. Now we're going to compare that to how many are consonants. There's an S, an M, an M, and an R. So there's 4 consonants. So what are the odds? Here's another thing with odds, ladies and gentlemen. You want to leave it in a ratio or a fraction. But we don't change odds to decimals or percents. Do we reduce it? Yes, we do. 2/4 becomes 1 to 2. So our odds of selecting a vowel are 1 to 2. Leave it as a ratio. Probability, usually we put that as a decimal or a percent, but odds we leave as a ratio because we're comparing two things, favorable outcomes to unfavorable outcomes. Another thing we have to be careful with odds is sometimes they throw probability in with us. Again, odds is what we want to have happen, our favorable outcomes, compared to our unfavorable outcomes. In this case, we'll say our odds are the probability that the event is going to occur compared to the probability that the event will not occur. So we have this little formula here, and I know it's going to seem a little confusing, but stick with me. To figure out the odds, if we know the probability, we can take the probability that the event will occur over 1 minus the probability the event will not occur. What does that mean? Oops, I apologize. And I'm sorry, this should say will occur here. I apologize for that. To be the probability the event will occur over 1 minus the probability the event will occur. Okay, so here's what that means. We want to find the odds of, let's say, this example. The probability that a randomly chosen 4-digit security code contains at least 1 0 is 0.34. At least 1 0, that's our probability, is 0.34. Again, probability given to us as a decimal. What are the odds that a 4-digit security code contains at least 1 0? So we are looking for the odds. In this case, the probability the event will occur, what event are we talking about? Well, we're going to talk about the probability of having a 0. And we're going to compare that to not a 0. Odds. What we want compared to what we don't want. Well, in this case, we're talking about probability, and we want to list it in terms of odds. So, if we know the probability, the odds of something happening, we take the probability that the event will occur. Well, what is the probability? Right here. The probability that it contains at least one 0 is 0.34. Now we're going to compare that to when it's not a 0. We're not given that information. So you need to understand this one right here. When we talk about probability of something happening, if it happens every single time, we represent that with a 1. We represent that with 100%. We can say with certainty that something's going to happen if we say the probability is 100%. So, in this case, think of this being out of 1. If you think back to the video you watched on probability, we had that number line, and we went from 0 to 1, 1 being certain. So that's where this 1 minus comes from. I can figure out how it's not going to be a 0 if I go 1 minus 0.34. It might be a little difficult to understand, guys, but it's just trust me on this formula. If we know the probability and we want to figure out the odds, you take the probability the event will occur over 1 minus the probability that the event will occur, because that's going to give us how many times it doesn't happen. This ends up being 0.34 over 0. And if I subtract correctly, 66, I hope. And I again will apologize if I'm wrong. Now, remember, on this last side, I said we had to leave it as a ratio. We don't write decimals inside fractions. So, we can rewrite this just by moving the decimal place over as 34 over 66. All I did, you guys, was moved it over 2 spots in each. I can do that because I did the same thing to the top and bottom. Okay? And I'll rewrite it up here. 0.34 over 0.66 is the same thing as 34 over 66, but we can take it one step further. We can divide both top and bottom by 2, treat it just as like a fraction or a ratio, and we end up with 17 over 33. What are the odds that a 4-digit security code contains at least one 0? 7 to 13. I'm sorry, 17 to 33. 17 times is favorable compared to 33 times where it's unfavorable. Again, ladies and gentlemen, make sure you have this formula here written down. And try to keep in mind how odds and probability are different. Probability compares successes to total number of trials, where odds compares successes to not successes, or favorable outcomes to unfavorable outcomes.